Okay, today we're here in the shop. This is where I work. Okay, and what we're working on here today is a Beckett. This is a fuel oil burner, and what we're going to do today is we're going to check this cat cell to make sure if it's good or not. We're also going to pull out the burner and learn a little bit about the nozzles today. So basically what I have is a jumper wire hooked up here to the cat cell, and we're reading resistance. And what we're going to do is we're going to cover up the cat cell, and that's going to give us a reading of about 54 point whatever. And then when I take my finger off the cat cell, that is going to change the resistance, and that's what we're going to have, 270.5. And what the cat cell does here is that when it's not seeing a flame, here that's covered and that's uncovered. Okay, and what that's telling me is that cat cell is reading and is working properly. And so when it sees the flame, it's going to read one resistance, and when it's covered, it's going to read another. Now, that's telling me this cat cell is working properly. If you hook up your probes to it, and you hook it up to your meter, and you cover that up, and it doesn't change resistance like that, then you need to replace your cat cell, because what happens is they get fogged up, they get misted up, they get dirty, they get burnt, they go bad, and this could cause you not to see the flame. The flame will come on, the cat cell will not register the flame, and it will shut down the control, and then you won't have any spark. Okay, so the cat cell, that's how you test them to see if they're working properly. Now what we're going to do is we're going to pull this burner out of there, and what we're going to do is we're going to loosen the bottom like so. Okay, and we're just going to loosen it a little bit. Of course, you're going to kill the power before you do this. Then you're going to loosen the top a little bit. Okay, once you loosen the top, you're going to take the nut off, and the whole thing swings out of the way. See, it just swings right out of the way. Okay, so that's how you. So what we're doing here is we're removing the burner to get to the nozzle. Okay. What else we have here is we have, and what you want to do is check where the mark is here, because you want to put this plate right back where it is. If it moves, you want that to go right back where it was. Okay. We are going to turn this. Once we take that off, we're going to reach inside. We're going to turn the burner upright like this so that we can pull it out. Okay. This one has pretty long probes. It's a little difficult to get out. But once we get it out, we're going to examine the electrodes on the end there. See how the electrodes are? And there's the nozzle. Okay, so we have a 2.5. What does that mean? That's how many gallons per hour this particular nozzle uses fuel. It is a 60 point A. What is that? That's the angle. Okay, and the A stands for hollow, semi-hollow, or W, which is like a universal. And in that little screw right there, you loosen that up to adjust the probes. Wrench, you put it on here like this. You take your second wrench and you put it on the nozzle like this, and see how the two wrenches are apart. You squeeze them together, and look how easy that nozzle comes right out of there. Okay? So you would take that off, get your new nozzle. You don't assume that this nozzle is correct. You want to look on the furnace and you want to look what range it is. It could run from range, like say you have a 6.5 and then on the furnace it says 6.5 to 7.5. It's telling you the radius, and you can control the BTUs of your furnace just by putting in a nozzle that burns a certain amount of gallons per hour. So in other words, if it's rated at 0.75 and you want to cut down the BTUs, you would put a 6.5, because it says right on the label from the range of 6.5 to 0.75 or 0.65 to 0.75. So you can put a nozzle in between there, but the angle you cannot change, or the AB, because you have to use the proper angle and semi or hollow nozzle. You cannot change that, but you can change the amount of per gallon that the unit uses. In other words, if you put your analyzer in there, you want a flue pipe gas of 325. Why 325? Because 325 degrees causes the moisture to evaporate in the chimney and go out the top of the chimney. If it's lower than that, the humidity will sit in the chimney, it'll rot things out. So you want from 325 and no more than 450 degrees Fahrenheit going out the flue. So how do you adjust that? You adjust, you can adjust it by changing the amount of BTU in the nozzle, and also you can change your air ratio on your burner, which we will get to that. But for now, we're just talking about the burners, the nozzle and the electrodes. Now that we've found a clean nozzle to the proper size and we put it back in there, the same thing. See how my wrenches are? And then you just give it a little tug. Now that's nice and tight, and that nozzle is secure. Now we want to adjust our electrodes. Okay? So how do we adjust our electrodes? Well, we will loosen this screw right here. A lot of guys do it by eye. You can do it. I've done it by eye for years, but they have this nice neat little tool here. You slip it over the nozzle and then you put the electrodes to fit right on there, just like this. You see that? And then once you get them right where you want them, which is right there, we are going to tighten down this screw, which will hold them right in place. So there you go. And now you'll slip this plastic piece back off, and your electrodes are now set in perfect position for spark and ignition. Once you have cleaned, sandpapered and cleaned your electrodes and you see that they're not burnt off, you have a clean nozzle, proper size, which you're looking at per gallon per hour, and you're looking at the angle, and you're looking to see if it's semi or hollow flame. Okay, you are going to put it back into the burner like so. Okay. You're going to turn it so that it can fit down in there. Slip it back through the side like that. You're going to put your nut back, your sleeve back on there. Okay. Give it a little tug. And to get your proper air adjustment, you'll need a smoke gun, you'll need an analyzer, and you'll need to know what your flue pipe gas should be, temperature, and you're going to have to know what your CO2 and your CO should be. And to adjust that, you have a sleeve and collar right here, and you have a little screw you loosen this up right here, and you can adjust this shutter for air intake. Okay? And once you get it to the proper CO2, proper flue pipe gas temperature, and O2, then you would tighten it down. Now we're going to get into all that. We're going to put an analyzer into one of these things, and we are going to analyze what your flue pipe gas temperature is and what your O2 and CO2 is, and we're going to actually adjust one of these burners to run properly. So basically what we just learned is how to remove a nozzle, how to remove a burner, and how to check and make sure that you have a cat cell that is operating properly. And that is on a Beckett fuel oil burner. The other thing you want to do is when you have this thing all tore apart, is you want to take a flashlight and you want to look down in there, and there's actually a plastic drive that goes from the motor to the fuel pump, and you want to examine to make sure there's no pieces of plastic down there, or your squirrel cage is spinning properly. You know, you want to make sure that it's spinning and there's nothing broke, and it's connected right here, and it's a plastic tube, a shaft, and it's all intact. Okay, so there you have it. We have just learned how to troubleshoot a cat cell. We learned how to remove a burner and remove the nozzle. We learned how to adjust the electrodes, and the next thing we're going to learn how to do is actually change the fuel filter on the fuel tank, and we're going to learn how to put an analyzer in the flue and adjust the burners. So there you go. Okay, the next thing you want to look at is these transformers right here. Okay. Alright, basically you open it up, you take your voltage meter, you trace down these two wires, and you make sure that they're getting 120 volts. If they are, you take a well-insulated screwdriver and you put it on one spring like that, and you come very close but do not touch, and it should throw an arc from that screwdriver to that spring. If it doesn't, and you touch it and it's just a barely little spark, that tells you that transformer is no good. But if you're holding it about a ½ inch away and it throws an arc around there like Frankenstein, then that's a good transformer and it's working properly. I just had one the other day where I did this test, and I actually was able to touch each other and had like a very faint spark. That told me that this transformer was not putting out the proper spark, and I replaced it. The fuel oil furnace fired right up. So basically you hold it away just a little bit like that, and it should throw an arc from that spring to the screwdriver, and that tells you you're getting proper spark. Remember, you must have a well-insulated screwdriver, because if you put a screwdriver on that isn't insulated, it's going to knock you across the room. It's going to hurt you bad, okay? So once again, if you touch that spring and you touch that one and you're getting hardly no arc, then that's the issue.